Hello children, hopefully you are going fine with health. Yes, there is some problem because you can't go out now. It's almost a house arrest situation. Many of you are missing traveling, even me too. And many of you must be missing the trips on school buses. Remember? Okay, I just have a doubt, children. When you were kids and your parents or guardians assisted you while just coming to school and getting into the school bus, when you were inside the school bus, you used to say tata or bye bye to your parents, and your parents also might have waved to you. So, the way you used to see the environment from the school bus, is it exactly the same how your parents would see the situation? To be more defined, what I want to mean, when you are inside the bus, you are, after a certain time, the bus is starting and you, whatever is there outside, like your parent waving at you, the trees outside, the other vehicles, don't they seem to rush backwards? And is it the same when you get down from that bus or see other buses going in front of you? Or is it like that you are standing and the buses are rushing one by one when you are outside? So at first, when you are inside the bus, you are seeing the things are rushing. When you are outside the bus, you are seeing yourself constant and the bus is rushing. Isn't it a confusion? Ever thought of it? Many a times. So that means numerous events are taking place together at the same time. The thing is how we perceive it. For example, let me bring you a very common and a local vehicle. Yes, correct, rickshaw. In this case, if I just focus on it, you can see that there are three people. Two, the passengers inside, and the third one is the driver, or most commonly said the rickshaw puller. They are sitting and they are enjoying the ride and they are going somewhere else. On the other hand, this driver is just continuously keeping these legs in motion and traveling. For them, they can see the outside whenever they want. For him, he has to keep his eye continuously at a watch on the roads. So, everyone, though at the same time in the same vehicle, are not seeing the same thing. Then, if I give you something to calculate based on this bus or based on any other vehicle like this car, how will you calculate it? Like the speed, the motion, and everything? Of course, data will be provided, that's a different issue. But the first question comes, ma'am, where will I be? Will I be sitting as a passenger inside the bus, or will I be seeing it? That means your position is relating or with relate to the outside incidents happening is the major thing. Now, as we very well know that physics deals with universe, its eternity according to me, I don't know what according to you, it deals with every possible thing. Even if you have any memory of the class 10 textbook, those who liked it or those who studied, you might have studied about radioactivity, which deals with small parts such as nucleus, or you might have dealt with gravitation and work energy and light, which is traveling outside. So in this case, if I talk about the celestial bodies, among all the solar system, it's only Earth which has such a huge gravity, almost 9.8 meter per second square. Now, and what is for the rest? Of course, when we go to moon, the people, not we, it's not so cheap and convenient till date, but those astronauts and the satellites, they find it very difficult because the gravity is 1/6 of that Earth, sorry. So if we talk about this exosphere totally, there is zero gravity. So what we perceive from the earth, will it be same if we go outside ever, or those who really want to? Not possible. In fact, as heard from different astronauts, if you ever go through their interviews, the first difficulty is to digest the point that I don't have any ground to stand. Yes, because there is no gravity. Where will I stand? And if I slightly displace, it's a huge displacement compared to that of Earth. Right. Anyways, coming back to our Earth and our topic, that means where my position is the prime factor. For a classroom, if I compare the students, I think in this case, many students are very, very angry. Even I used to be, believe me, when I used to be a student. And I also used to be from ICSE board. It is only the students who need to wear uniforms. For the teachers, of course, they have to wear formals, but they can at least change their colors. Students can't. So similarly, position is a major point, and this position in all the surroundings and system is termed as point of reference. In your book in chapter 3, I know many can't have the book, so that is the reason I send the PDF. Yesterday itself, I suppose you have got it. If not, please check the Parents Alarm regularly for the updates. And in the e-content it is provided the full PDF of the chapter. The name is Motion in a Straight Line. The first point comes as frame of reference. The frame of reference means, as I have told or I was explaining from the beginning, see, pardon me for the drawing. I know I am not very good at it, but it is just for explanation, so I suppose it will be working. In this case, I have now when I talk about frame, it is not necessary to be a particular square or a photo frame. In this case, the coordinates of the axis will work. I know that already you have been very thorough with the topic graph in your mathematics particularly, and physics from time to time in varied chapters. So see here, as you can see, I have only taken the first quadrant or the positive quadrant, since I am dealing with time and motion, and the y-axis positive and the x-axis positive portion. Here, as the frame of reference, the first thing comes is where am I with respect to the moving bus. As you can see, over here, my finger, that a very bad figure is drawn. So it signifies a different frame where the person is standing and seeing that the vehicle to be moving, or else where you can see the arrow drawn on the top right over here to signify whether the passenger is inside the bus. This will differ the point of reference and the frame of reference. What I feel, what I perceive has to be very clear from my viewpoint. One more example, and I suppose this is very clear, and I'm giving this example because numerous explanations, and not only explanation, numericals do come on this concept. Cricket. Two teams, and one person is fielding, one person is batting, I'm extremely sorry, and it can be your favorite cricketer, MS Dhoni, Virat Kohli. It can be someone from the opponent team, but still your favorite, AB de Villiers. So other fielders are there, total 11. 11 people are watching one batsman, but one batsman is watching the bowler who is trying to give the ball, or the other persons where their positions are. So what I perceive is totally different. Batsman is on the pitch exactly. Bowlers can be at the boundary, wicket keeper near the stump. So everyone has a different point of seeing. So where you are seeing, where you are looking, it's extremely important from the point of our subject, which is physics. So this was the main point of frame of reference. Now this frame, whenever we talk, we try to confine it, and that is the reason I drew this coordinate axis, x-axis and y-axis together forming the quadrant, so that you know that we need to plot a point. We need two coordinates, x coordinate and y coordinate. This coordinates can signify plotting of the points, or like over here as I drew, that it can signify the person's position. So my perceived point is too important. Next comes one more topic related to this motion or traveling only. Right now, from the beginning, I was talking about the bus getting in, moving in or outside. Now suppose this bus is going from your home to our school. While coming from my house, if I say my original house to St. Claret, it takes approximately just 3 kilometers or 2 kilometers to 3 kilometers maximum, like that. One question arises. See, the bus is having 4 wheels or 6 wheels, 8 wheels in the case of the larger ones. Another thing, this bus is not just a small dot. So this bus is also having a length. Where did this length go? The bus is almost 3 meters or 4 meters in size. So, whether the bus stands with this last position in front of your house or this first position only in front of your house, or only with the doors facing your house, the bus has reached its destination. So how will I calculate the exact distance? Isn't it really cumbersome? I need to know the distance of the length of the bus, and again I will calculate it 2 kilometer, 3 kilometer, or even 30 kilometer, 40 kilometers per the distance required. So what will I exactly calculate? How are then these distances calculated? If the length of the bus is getting included, if I drive a small car, then the distance will be different. A small car, suppose like this, then the distance or the length will be different. If I am in a bus, then the length will be different. So how to calculate? Isn't it really confusing? An easier part for the confusion. Hold on. When my bus is, kindly see this below diagram, ignore the top one. This full length in accordance with this length is traveled. We simply ignore the total size of the bus. I am at my point of reference, that is my doorway, when I am getting in the bus to go to the school, or I used to go in school bus only. Many of you still go in. And the second point is that of the school's main gate, where the bus is going to drop me. In between, the bus was very big, the bus was very nice, the enjoyment which happened in the bus was also very good, a boost up for the early in the morning. Maybe you have some best friends or your cousins or sisters or brothers also accompanying you, that was also a good time. We ignore all those incidents when we enter the school. Similarly, we ignore the mass. I just consider this only as a single point mass. Just hold on, please. The bus is actually not shrinking. We are ignoring the bus because I need to travel. So the lengths are normally, or the distances are normally much ignorable than the size of the bus I am in. Now for us it can be a question, ma'am, how can I ignore the whole bus or the truck which is so big? Think of someone traveling from one city to another. West Bengal, beside there is Jharkhand as a state. So from Kolkata to any place in Jharkhand like Ranchi, Jamshedpur, if someone is traveling by bus, taking the time of around 12 hours, 18 hours, 24 hours, it depends. In that case, isn't the bus becoming very small? So just ignore it. What we consider is it to be not the whole bus over here. We simply scratch out the buses or the taxi or the Ola Uber cabs, something like that over here. We simply talk about a point traveling from one place to another. Because it is me who is traveling. I am calculating, or my family is going, my friends are going, we are going together. I need to calculate. What means of transport? Ignorable. How I am going, that I need to consider, because that much fare I have to pay. Petrol prices, fare of the bus, fare of the car, whatever. So that I need to know. Size of the transport, ignorable. So that is the reason we consider it to be a point mass or a point object. Now, for the point object, yes, I can say, ma'am, you have given a dot, it suddenly shrinked to a point object. What is the size of moon with respect to the space? Or even what is the size of earth with respect to sun? Comparative study is always a good thing to consider in physics. In fact, many a times those are also considered. Those who already studied class 10 in this school itself, they might remember the lens experiment or the lens parts taught in the optics portion, and always there was a convention taken that the lens is to be very thin, and you did not draw the refracted rays through the lens, which was the initial diagram of the refraction through lens chapter. So we ignored the size of the lens while the light rays passed. Similarly, we will ignore the point mass or point object. Now, when all these things are coming in, you can easily understand that we are talking about motion. There are various types of motion. What type? Motion in one dimension. That means in a very disciplined way, all the students of the class are making a line one by one and going back to the class. I am standing, Namrata ma'am is standing, principal is standing, Anita miss is standing, Kaushik sir is standing, and all the senior and serious teachers are standing and observing you. If everyone would have left, how would you have traveled? So, that is a different concept. So, motion in a straight line, exactly in one line. But in a difficult or a fully busy road, for example, the roads near Barakpur station, near Barashat stoppage, are they so clear and easy to go? In fact, when you ride a cycle also at all, I used to ride previously, didn't we have to continuously press the bell and go left, right, left, right, left, right and everywhere and make a chaos? So, that means in that case, this straight line is actually turning into a zigzag motion like this. Many a time cycles and buses and rickshaw vans do drive like this. In this case, a line is not possible to maintain. We have to go, we have to live. So this is particularly a motion in two dimensions. Why two dimensions? I have drawn it very bad and it is really difficult to see. So just give me a moment, please. In this case, you will see that the xy coordinate at this point and the xy coordinate at this point, it is not the same. Just like this one where the y coordinate was 0 but the x coordinate was keeping on changing at some way. In this case, both are changing every time. So this is motion in a plane or a two-dimensional motion. We will be coming to this in detail afterwards. Now, a motion in three dimension. For example, that means in this case, when I am throwing an object, what are the things happening? Kindly observe it. Number one, this is the coordinate in which it is hitting. That means this is the initial point. There is an xy coordinate. Going down, another xy coordinate. Rolling over comes the third axis in. X, y and z coordinate with a simply different direction. If you see an easier form, you can see on the top, it is actually the frame of the bed, but the corner, it can easily signify the three axes. X axis, you can take the top bar on my head as the x. The y axis, of course, the longitudinal one or the straight one coming up and down, and the z axis, which is defining the third dimension. So in this case, you can easily signify the position if I throw anything with this direction or in the three dimensions. So these are basically the three dimensions we keep on talking about. So I request you to kindly go through the PDF, or if you have the textbook, that's really great in this case, so that you can go and read in details about these two parts of the book. There are few terms given: speed, distance, displacement, velocity. These are already known to you, but we can get to know them better very soon and with some of additional informations. So for that, please follow the next class. Good night or have a good time. Bye bye.